Okay, today's lesson is about the gradient at National 5 level. We'll explain what the gradient is and how to calculate it. Well, the gradient just tells you how steep a line is. It's the slope of a line. So let's define that. The gradient is simply how steep a line is. The bigger or more steep the gradient is, the bigger the number when we calculate it. Okay, and there's 4 different types that you can get. We'll define each one of them. Okay. First one, a line sloping from left to right up the way. That's called a positive gradient. It goes from left to right up the way. We use m for the gradient, so m greater than 0. That's your first one. Positive gradient. Imagine you're taking off going on holiday and the airplane's going up the way. It's positive, you're in a positive mood, positive gradient. The next type is a horizontal line. I've met this before. A horizontal line. And the slope is not going up the way or down the way, it's horizontal. So the m is equal to 0. And just remember the word horizontal. Horizontal tells you that the gradient is 0. Quite important. Third type is line sloping down the way. And surprise, surprise, the gradient for this one is less than 0. It's negative. So if you've got a negative number, then you know that your gradient is sloping down the way. The more negative, the steeper the downward slope. And the last one that you won't really meet at National 5, but we'll mention it anyway, tends to come up at higher quite a bit, is a vertical line. Now a vertical line, we can't calculate the gradient for a vertical line. It's undefined, so the gradient is undefined. Undefined. And just put the word vertical here. So as you hear vertical, you can't work out the gradient. Horizontal, gradient 0. And the other two are either positive or negative. Now, how do we calculate the gradient? Well, I'm going to show you that in a wee minute. So, I'm going to make up a coordinate grid. There we go. We have the origin. Then we'll have the x-axis. So here's the origin here, x-axis and the y-axis. Now I'm actually going to show you where the equation comes from. You don't have to know this for National 5, but it's nice to appreciate where these things come from, especially if they're easy to work out, and this one's pretty easy. All you have to do is remember the formula once we get there. So let's see how we do it. Well, I'm going to refer back to the positive line I just drew up at the top there. The way we work it out is we form a right angle triangle, and this is the vertical height here, and that's the horizontal distance. And when we take the vertical distance and we divide it by the horizontal distance, that value is the gradient. That's what we call the gradient. Vertical divided by horizontal. And whatever value that is, that's how steep our line is. At National 5 level, we tend to use coordinates, so I'll just show you how we work it out using coordinates. On my grid here, I'm going to put a point in here, and I'm going to call it x1, y1. So x1, y1. And another point up here, we'll call that x2, y2. And I'll just draw a line between them. So how steep's that line? Well, first step, find the triangle, the right angle triangle. So we have to work out this vertical height here and this horizontal distance. So from coordinate work before, you should know if I put a horizontal line along here, this is the y coordinate and it's y2. We've called it y2. So this value here is the same as that value there for the y coordinate. Same idea for this one, the y coordinate for this one, y1. So this distance here is the same as that distance there, and this is the distance we want to calculate. So y2 minus y1, so this distance here is y2 minus y1. And we can do the same idea for the x coordinate. So this is x2, and this is x1. And this distance here that we want to calculate is x2 minus x1. So this distance here is x2 minus x1. And we're practically there. So the gradient formula is y2 minus y1 divided by x2 minus x1. And that's defined as being how to work out the gradient for a straight line. And we're now going to use that for some real life examples. Okay, so I'll just rub this out and we'll do some examples. So let's stick to a positive gradient, an easy one to begin with. So we pick any 2 points, so we just make them up. So let's make some of them up. Let's make that one 1, 2, keep the numbers simple, and try this one up here, and we'll call that 4, 3. And we have to work out what's the gradient once we put the line in. So we'll connect the 2 points together and work out the gradient. There we go. So in a right angle triangle, just roughly, and we work out the gradient. So m is equal to, well, y2, well, y coordinate, so we'll make that y2, so that'll be 3 minus y1, which is 2, all over x2, which is 4, minus x1, which is 1. So that gives me 3 take away 2 is 1, 4 take away 1 is 3, a third. So the gradient for that line is 1/3. Now, we should know a rough answer before we start. We know it's a positive gradient, so this value here must be positive, and it is positive, so we can reasonably assume that our answer is correct. That's a positive gradient. Let's try a horizontal one, so rub this out. And we'll try a horizontal one. Well, horizontal means that the y coordinates are the same. So let's do a coordinate. Let's go for 2, 3. And the next one, let's make that 4, 3. Draw a line in between the 2 coordinates. There we go, and we'll work out this gradient. Well, m equals, we'll make this y2, so y2, which is 3, minus y1, which is 3, over x2, which is 4, x1, which is 2. So 3 take away 3 is 0, so that's 0 over 2, which is 0. Horizontal line, that's what we needed to get, because a horizontal line has gradient 0, and we've just proved it. Let's try a negative gradient. So this time I'll just draw a line, I think. Draw a line. And we'll attach values to it. Okay, so let's call that 1, 5. 1, 5. Let's call that, say, 4 along, 2 up, 4, 2. And let's work out that gradient. Again, draw the right angle triangle. And m equals, the y2, let's make y2 2, so that's 2 minus y1, which is 5, over x2, which is 4, minus x1, which is 1. So that gives me minus 3 over 3. Minus 3 divided by 3 is minus 1. So the gradient is minus 1, as expected, because it's a negative slope. And that's 3 types. The vertical type, I won't do the vertical type here, you'll not get that at National 5, but we would get the bottom to be 0, and anything divided by 0 we can't do, it's undefined. So that's how that one comes about. But I wouldn't worry about that one. I'm going to do one more when we've got negative coordinates, because that comes up quite a lot in National 5. So I'll show you an example of that. So I'll just wipe all this away. And this time, I'm going to do 4 quadrants. So here's the 4 quadrants. And I think I'll probably do the hardest one. I'll do a negative slope. So we'll put something like that down. So there's the origin, there's the y axis, and there's the x axis. Now we need 2 coordinates, so let's put 2 coordinates in. And let's put something reasonable. Minus 3, 2. Okay, so make this minus 3, 2. And this one here, well, let's go along with it this way. Say 4 and minus 4. 4 and minus 4 seems reasonable. And let's work out the gradient for that. Well, we know we have to get a negative value because it's sloping down the way. Let's see what we get. So m is equal to y2. Make this y2, so that's minus 4. Minus y1, which is 2, over x2, which is 4, minus 3. So we've got to be careful here. Minuses everywhere. So the top part, minus 4 minus another 2 is minus 6. And the bottom part, 4 minus 3, well, subtracting a negative, the same as adding, so that's 4 plus 3, which is 7. So the gradient is minus 6, 7. As expected, negative slope. And that's all there is to gradient. A couple of wee pointers that I think is well worth remembering. Here's a line, and here's another line, and they're parallel. So I'll put the arrow to say they're parallel. Now, if they're going in the same direction, when you calculate the gradient, because they're going in the same direction, they have the same slope, then the gradients are the same. So parallel lines have the same gradient. That's handy to know. That can pop up in a question. And it's, if you don't know that, then you can get stuck on these things. Okay, so that's all there is to gradient at National 5 level. If you want any extra help with that, go to mathsrevision.com, National 5, and the gradient will be under straight line section. Okay, there's plenty of practice there and online practice for you. Okay, thank you.